What if the silence of the universe is not peaceful at all? What if every civilization that ever became advanced enough to unlock the deepest secrets of physics accidentally erased itself before it could ever speak to the stars? For decades, humanity has stared into the night sky searching for evidence that we are not alone. We built radio telescopes, scanned distant planets, and imagined ancient civilizations quietly expanding across the galaxy. We comforted ourselves with the idea that intelligent life, once born, naturally survives long enough to master the cosmos. But there may be a terrifying flaw hidden inside that assumption. The universe may not be empty because life is rare. It may be empty because advanced intelligence always reaches the same final discovery, and that discovery destroys it. Think about a strange thought experiment for a moment. Imagine walking through a massive automated mansion larger than an entire city. Thousands of rooms stretch endlessly in every direction. Every room is perfectly preserved, climate-controlled, spotless, and filled with incredibly advanced technology. At the center of each room sits an identical console, polished and waiting. Every console carries the same promise. Whoever completes the final operational sequence will gain access to unlimited free energy, infinite power, total mastery over physics itself. At first, the mansion feels exciting. You assume the builders moved on long ago or evolved beyond needing the place. But then something begins to bother you. Every room is empty. There are no signs of life anywhere, no records of departure, no evidence anyone ever succeeded. So you begin studying the consoles themselves. Eventually, buried deep inside the operating code, you uncover something horrifying. Every console contains the exact same fatal flaw. The moment someone successfully activates the final sequence, the system triggers an unstoppable energy discharge that vaporizes the console, the room, the operator, and a massive section of the mansion instantly. Suddenly, the silence no longer feels mysterious. The silence becomes evidence. That exact possibility may exist inside the structure of our universe itself. And to understand why, we first need to abandon one of the biggest misconceptions humans have about reality. Empty space is not actually empty. What we call vacuum is not a calm, motionless void. At the quantum level, space is alive with fluctuating energy fields constantly interacting beneath the surface of reality. Even when every particle and every photon is removed, those fields remain active. Among all those fields, one matters more than almost any other: the Higgs field. You interact with it every second of your life without ever noticing it directly. The Higgs field is the reason matter has mass. It is the reason atoms can form stable structures. Without it, chemistry would collapse, stars would never ignite, and biological life could never exist. In many ways, the Higgs field is part of the invisible foundation holding reality together. Now here is where things become deeply unsettling. After scientists discovered the Higgs boson at the Large Hadron Collider, they gained enough data to calculate something extremely important about the universe. When researchers inserted the measured values into the equations of quantum field theory, the math pointed toward a disturbing conclusion. Our universe may not exist in a perfectly stable state. Instead, the Higgs field appears to sit inside what physicists call a false vacuum. To visualize this, imagine a vast energy landscape made of hills and valleys. Our universe currently sits comfortably inside one valley. Everything works normally here. Atoms bond together. Gravity behaves predictably. Life evolves. But according to the equations, this valley may not be the lowest possible state. Somewhere deeper in that landscape exists another valley with even lower energy. Physicists call this the true vacuum. And the difference between those two states is not minor. Inside the true vacuum, the laws of physics themselves would change completely. The fundamental constants controlling matter, energy, and atomic stability would all become different. Chemistry as we know it could not survive there. Biological structures would instantly collapse. Even the forces holding atoms together might cease functioning entirely. The truly frightening part is this. According to quantum theory, our current vacuum state is not permanently secure. It is metastable. That means it can survive for an incredibly long time, but not necessarily forever. Under normal conditions, the probability of collapse is unbelievably small. so small that it seems irrelevant on human timescales. But unlikely does not mean impossible. And this is where the mystery of the silent universe suddenly becomes terrifyingly relevant. Every advanced civilization eventually follows the same path. It builds larger particle accelerators. It searches for unlimited energy. It pushes deeper into the quantum structure of reality itself. Technological progress naturally drives intelligent species toward higher and higher energy experiments. But the closer a civilization gets to mastering the vacuum itself, the closer it may come to destabilizing the very field that keeps reality intact. The terrifying possibility hidden inside quantum physics is not simply that our universe could end one day. The truly disturbing part is how easily the process might begin. According to modern quantum field theory, reality itself may be balanced on an invisible edge, and any civilization advanced enough to manipulate enormous amounts of energy could unknowingly push it over that edge forever. To understand this, we need to look closer at the idea of the false vacuum. Imagine once again that giant energy landscape filled with valleys and hills. Our universe currently rests inside a valley that appears stable. Stars burn normally, matter behaves predictably, life exists, but somewhere deeper in that landscape lies the true vacuum, a lower energy state where the laws of physics are completely different. The reason our universe has not fallen into that deeper state yet is because an energy barrier separates the two. Under ordinary conditions, that barrier is incredibly difficult to cross. But quantum mechanics allows strange things to happen. At very small scales, particles can occasionally pass through barriers they should never be able to cross. This process is called quantum tunneling. Instead of climbing over the barrier, the particle simply appears on the other side through probability alone. Normally, this behavior only matters at microscopic scales. But according to the mathematics governing the Higgs field, the vacuum state of the universe itself may also be capable of tunneling. And if it ever does, the consequences are absolute. Physicists believe that if a tiny region of space tunnels into the true vacuum state, even at the size of a single subatomic particle, it would create what is known as a true vacuum bubble. Inside that bubble, the laws of physics would instantly change. Atomic structures would no longer function the same way. Electromagnetic interactions could collapse. Matter itself would become fundamentally unstable. But the bubble would not stay small. The enormous energy difference between the false vacuum and the true vacuum would force the bubble to expand outward in every direction at the speed of light. Not almost the speed of light, exactly the speed of light. Nothing could outrun it because nothing in the universe can travel faster. And that changes the entire meaning of cosmic silence. Imagine an advanced civilization somewhere in another galaxy. Over thousands of years, they build increasingly powerful technologies. They create massive particle accelerators. They learn to manipulate space-time itself. Eventually, they begin probing the deepest layers of quantum reality, searching for unlimited energy hidden inside the vacuum. At first, every experiment works. Their understanding grows. Their civilization becomes more powerful than anything humanity can currently imagine. Then one experiment pushes slightly too far. In one microscopic region smaller than an atom, the energy density becomes high enough to destabilize the Higgs field locally. The barrier separating the false vacuum from the true vacuum weakens for a fraction of a second. Then quantum tunneling occurs. That civilization disappears instantly. Their planet is consumed before any emergency signal can escape into space. Their star system vanishes shortly afterward as the bubble expands outward at light speed. Nearby systems follow. Over time, entire regions of the galaxy are erased, not through explosions or war, but through a complete rewrite of physical law itself. And the worst part is this: the process produces almost no warning. No radio message can outrun the expanding bubble. No distress call reaches neighboring civilizations. In many theoretical models, there would not even be a visible explosion. To a distant observer, a star system might simply stop behaving normally and vanish from detectable reality. Depending on the distance, that observation could arrive thousands or millions of years after the destruction already happened. This possibility transforms the Fermi Paradox into something far darker. For decades, scientists asked a simple question: If intelligent life should be common in the universe, then where is everybody? The galaxy is ancient. Even a moderately advanced civilization could theoretically spread across enormous distances over millions of years. So why does the universe appear silent? Maybe because every civilization eventually reaches the same dangerous threshold. The more advanced a species becomes, the more energy it learns to control. Every path toward unlimited power requires interacting with quantum fields at deeper levels, vacuum energy extraction, space-time engineering, advanced particle manipulation. All of these technologies move civilization closer to the conditions where vacuum instability becomes physically relevant. In other words, intelligence may naturally guide itself toward destruction. And this is not science fiction fantasy. The numbers behind this concern come directly from real measurements taken at the Large Hadron Collider. When physicists calculate the stability of the Higgs field using the observed Higgs boson mass and the top quark mass, the equations place our universe disturbingly close to the boundary between stable and metastable vacuum states. That detail matters enormously. If the vacuum were deeply stable, there would be little concern. But our universe appears balanced near a critical edge where small changes in energy conditions may become important. Some physicists describe this as near criticality, a situation where reality itself seems strangely tuned close to instability. Nobody fully understands why. And the closer researchers look, the stranger the coincidence becomes. Because if advanced civilizations naturally push toward higher energy experiments over time, then the universe may contain a built-in physical filter preventing any species from progressing beyond a certain technological level. Not through war, not through politics, not through biological weakness, through the mathematical structure of quantum field theory itself. The most unsettling part of this entire theory is not that vacuum decay might be possible. It is that the universe appears balanced dangerously close to the conditions where it could happen. When physicists studied the Higgs boson after its discovery at the Large Hadron Collider, they expected the numbers to place our universe safely inside a stable vacuum state. Instead, the calculations pointed somewhere far more disturbing. Reality itself seems to exist near a critical boundary between long-term stability and eventual collapse. That detail changes everything. To understand why, we need to look at how the vacuum state is actually described in quantum field theory. Most people imagine physical laws as fixed and permanent, like rules carved into the structure of the universe. But at the quantum level, many physical properties depend on something called renormalization. In simple terms, the behavior of fields changes depending on the energy scale being examined. As particle energies rise, the interactions between fields evolve. That includes the Higgs field itself. The energy barrier separating our false vacuum from the deeper true vacuum is not perfectly rigid. Its stability depends on precise values connected to fundamental particles such as the Higgs boson and the top quark. Tiny differences in those values can dramatically alter whether the universe remains stable forever, survives temporarily, or eventually collapses into a lower energy state. And according to the current measurements, our universe sits alarmingly close to metastability. This strange balancing point is known among physicists as the near criticality of the electroweak vacuum. Nobody knows why reality appears tuned so close to the edge. Some scientists argue it may be coincidence. Others suspect deeper physical principles are involved. But regardless of the explanation, the implication remains deeply uncomfortable. The vacuum may be more fragile than humanity realizes. Now combine that with the natural progression of technological civilization. Every intelligent species driven by curiosity eventually learns to manipulate larger amounts of energy. Human history already demonstrates the pattern clearly. We move from fire to electricity, from chemistry to nuclear fission, from classical mechanics to particle physics. Each step pushed us deeper into the structure of reality itself. And every generation of scientific advancement demands higher energies and more precise control over quantum fields. There is no reason to believe this process stops naturally. Eventually, any sufficiently advanced civilization would likely attempt technologies involving vacuum energy extraction, space-time engineering, or direct manipulation of quantum fields. Theoretical concepts such as warp drives, artificial wormholes, and zero-point energy systems all rely on interacting with the vacuum at extremely deep levels. In fact, the dream of accessing unlimited energy almost certainly requires probing exactly the region of physics where false vacuum instability becomes relevant. And that may be where the trap closes. Because the probability of vacuum decay is not necessarily fixed under all conditions. Under ordinary circumstances, spontaneous tunneling into the true vacuum is so unlikely that it may not happen for periods vastly longer than the current age of the universe. But advanced energy experiments change local conditions. As enormous amounts of energy become concentrated into smaller and smaller volumes, the effective barrier separating vacuum states may weaken. The closer a civilization gets to mastering fundamental physics, the closer it may move toward destabilizing the vacuum itself. This is what transforms the silence of the cosmos into something terrifyingly logical. Imagine millions of civilizations scattered throughout the galaxy over billions of years. Most remain primitive and disappear naturally through ordinary extinction events. But a small fraction survive long enough to develop advanced science. They build massive energy systems. They unlock quantum engineering. They approach the threshold of subatomic mastery. Then one day, somewhere deep inside an experiment designed to achieve infinite power or complete spacetime control, the local energy conditions cross a critical limit. A true vacuum bubble forms. The process is instantaneous. One moment, the civilization exists. The next moment, the laws of physics inside that region no longer support atoms, chemistry, planets, or life itself. The expanding bubble spreads outward at light speed, erasing everything in its path before information can escape ahead of it. No warning reaches neighboring civilizations. No evidence survives long enough to become an archaeological record. From the outside, entire regions of space simply go silent forever. This possibility introduces a terrifying answer to the Fermi Paradox. Advanced civilizations may not leave behind giant structures or detectable radio signals because the universe contains a built-in physical filter operating at the deepest level of reality. Intelligence evolves naturally. Technology advances naturally. Curiosity drives civilizations toward greater power naturally. But eventually, physics itself may impose a hard limit no species can cross safely. And humanity may already be moving toward that same boundary. Modern particle accelerators are nowhere near the energy scales believed necessary to trigger vacuum decay. Most physicists agree the Large Hadron Collider poses no threat. Cosmic rays striking Earth's atmosphere regularly produce higher energy particle collisions naturally. But the danger lies much farther ahead. Civilizations millions of years more advanced than humanity would almost certainly attempt experiments operating on scales we can barely imagine. The question is whether any civilization can stop itself before reaching the critical threshold. History offers little comfort there. Technological progress rarely slows voluntarily. Scientific discovery creates competition. Competition drives acceleration. If one civilization believes another may unlock ultimate energy first, the pressure to continue becomes overwhelming. Eventually, the pursuit of deeper knowledge may become impossible to separate from existential risk. If false vacuum decay ever begins, there is no emergency response, no evacuation plan, no defense system, no technology, no matter how advanced, can stop it once the process starts. That is what makes this theory so terrifying. Most existential threats humanity imagines still operate within the laws of physics we already understand. Asteroids can theoretically be deflected. Pandemics can eventually be treated. Even nuclear war leaves behind survivors and physical remnants. But vacuum decay is different because it does not destroy objects inside the universe. It rewrites the universe itself. The moment a true vacuum bubble forms, reality on the inside follows an entirely different set of physical laws. To understand the scale of this, think about the role physical constants play in ordinary existence. The strength of electromagnetism controls how atoms bond together. The masses of elementary particles determine whether chemistry is possible. Nuclear forces regulate how stars burn and whether matter remains stable. Life depends on a delicate balance between all these interactions. Even small changes could make atoms impossible or prevent stars from forming entirely. Inside a true vacuum bubble, those constants may change completely. The Higgs field would settle into a lower energy state, and every particle interacting with it would behave differently. Electrons might no longer bind to atomic nuclei. Protons could become unstable. Chemistry could collapse instantly. Matter itself may disintegrate into forms unrecognizable to anything that once existed in our universe. And the transformation spreads outward at the speed of light. This detail is crucial because it means no warning can ever arrive ahead of the event. Information itself cannot move faster than light. If a vacuum decay bubble forms anywhere in the galaxy tonight and begins expanding toward Earth, we would never see it coming. There would be no signal, no visible wave, no countdown. The first indication would also be the final moment of existence itself. That silence is what changes the Fermi Paradox into something deeply unsettling. When scientists search for extraterrestrial civilizations, they usually assume advanced species leave detectable signs behind: radio transmissions, Dyson spheres, artificial structures surrounding stars. But vacuum decay changes the logic entirely. If civilizations disappear through catastrophic quantum instability, they vanish almost without evidence. The destruction wave expands too quickly for distress signals to spread ahead of it. Entire star systems are erased before neighboring civilizations even realize something happened. From a cosmic perspective, advanced societies may disappear silently and completely. Now imagine this process repeating across billions of years. Somewhere in a distant galaxy, a civilization discovers how to manipulate vacuum energy. They believe they are on the edge of infinite power, perhaps preparing to reshape planets, build faster-than-light transportation systems, or engineer space-time itself. Their technology advances beyond anything humanity can currently imagine. Then one experiment pushes slightly too far. A microscopic true vacuum bubble forms inside a controlled chamber. Within seconds, their planet is gone. Hours later, their entire solar system disappears behind the expanding bubble wall. Centuries later, neighboring star systems vanish as the wave continues outward through the galaxy. Millions of years later, distant observers notice only that a region of stars no longer behaves normally. There is no explanation, no debris, no ruins, no warning, just silence. This possibility forces us to rethink the meaning of cosmic emptiness entirely. Maybe the galaxy is not full of ancient civilizations quietly hiding from us. Maybe advanced civilizations repeatedly erase themselves before they can spread far enough to become visible across interstellar distances. And the mathematics behind the Higgs field suggests the danger may be universal. The deeper physicists examine the parameters governing vacuum stability, the stranger the situation becomes. Our universe appears balanced, unnervingly close to the edge between stability and metastability. The values of the Higgs boson mass and the top quark mass seem almost fine-tuned to place reality near a critical threshold. Some researchers describe it as a coincidence so strange that it almost demands explanation. Why would the universe sit so close to instability? Nobody knows. Some theories suggest entirely new physics may stabilize the vacuum at higher energies. Others argue the metastability calculations may be incomplete. But if the current models are correct, then advanced civilizations everywhere face the same fundamental problem. The laws of physics themselves contain a hidden boundary condition limiting how deeply intelligence can probe reality safely. In that sense, vacuum decay becomes more than just a scientific curiosity. It becomes a cosmic filter. Most discussions of the Great Filter focus on biological evolution or self-destruction through war and environmental collapse. But vacuum instability introduces something far more absolute. A civilization does not fail because it lacks wisdom or morality. It fails because the structure of reality eventually punishes unlimited access to energy itself. And there is another disturbing implication hidden inside this theory. A civilization advanced enough to understand vacuum decay might never share that knowledge publicly. Imagine discovering experimentally that certain energy scales carry a non-zero probability of destabilizing space-time itself. Would you publish the exact conditions openly? Would governments allow unrestricted research? Would advanced civilizations deliberately hide from younger species to prevent accidental catastrophe?